Okay, we are going to start by looking at the handout that is in Module 4 in the learning plan. And I have the physical copy underneath here, but I did include the PDF copy in the learning plan for you. And I know that this is something that's just going to take a little bit of time, and it might not be the most exciting and the most glamorous, but it is essential to remind us of the good rules that we need to apply when we are doing our drawings. Okay, so the drawings you're handing in need to adhere to the ANSI standard. Okay, so this is a nice chapter that I found that is going to do that for us. I encourage you to read through this. I'm going to hit the highlights. I'm going to kind of, show you some do's and don'ts that are here. There's even a couple things that they do that I'm like, not quite right, but we'll talk about it. Okay, but take time to read this. This is actually a really good handout. So we're going to start over on the second page here. It's page 198. Okay, and in this figure here, there's a couple different things. First of all, it's talking about learn to dimension properly. That's what this section is talking about. All right, and when we look at the two views that they have here, a couple of things I want to point out that they're doing really, really well. So first and foremost, you're going to notice that many of the dimensions are between the views. Okay, that's going to be the first place that you're going to want to try to put the dimensions. Okay, now that doesn't mean that all the dimensions have to be between the views. So if there was a right side view over here, you would try to cluster them in the middle. Okay, only because they're easy to find. Okay, you don't have to like be searching all over. They're like centrally located. All right, but you'll notice that there are dimensions that are outside of this or towards the outside of the part. And that's when the space doesn't allow it, or the dimensions are closer to where the feature is at. So for instance, you're going to notice that they have this dimension up here. Well, if they would put this down here, do you see how it would start to get pretty cluttered in the middle there? So putting it on the top is perfectly fine. So a lot of these rules are like best practices. All right. Additionally, you're going to notice that when we have shorter dimensions, they're closer to the part, okay? And the longer dimensions are outside of those. You wouldn't put a longer dimension closer or inside and then cross over and have the shorter one on the other side. Creo is a machine. Creo is going to pull those drawings in or those dimensions in like we saw when we had been, starting the dimensioning in Creo to make a drawing. You have to place them where they need to go. You still have control over that software, and you are the one that is interpreting the standard. Okay, so you want to place these so that they're pulling out. Another thing that we see here is that there are gaps. Notice that our extension lines do not run into the part. They don't run over the top of features. They don't go into the center line. Okay, we had seen some examples of where we pull those away. You will have to do that on probably almost every dimension that Creo places. Okay, all right, so those are cleanup things that you're going to have to do. Additionally, you're going to notice that the leader that is calling out this hole, okay, this looks like it's a counter board hole. The leader has, first of all, a landing. That's what this is called. Okay, it doesn't terminate and then it just the note starts. You have to have what we call a landing first. Additionally, when this is pointing at the circular feature here, if we would extend that arrowhead, it would go through the center. Now, Creo will place that for you, okay? But you get to place this where it's going to go. And what you want to avoid, or the numbers that they say, you want to have your leader between a 20-degree angle and a 70-degree angle. Anything steeper or flatter is not good practice, okay? So you're going to want to find another place to put it if you have to, all right? Also notice that when you are putting a note that there are multiples of a feature, in this case, it's going to be this height dimension here. It's a 2 by. It's 2 by, and it's right before the actual dimension with a space in between. Okay. It is not by 2. I see that a lot, or by 4. All right. The X doesn't come first. It's 2 by, and the by has to be capital. Okay, every single piece of text on a drawing has to be in capital letters. There is no mixing of lowercase and uppercase. And yep, you might say, well, that's the way Creo did it. Don't care. Creo is a machine. Okay. You are the human. You have the brain. Okay. Additionally, you'll notice that they do have here reference after a particular dimension, because if we take the 0.44 and we add it to 4.12 and then we add 0.44 again, it equals 5. Okay. We can't, this would be called double dimensioning, because if we would use all of these with tolerances, they wouldn't add up to this. Okay. So you have to pick something in the line, if you would, that you are either going to reference or leave off. Okay. And most often we just leave it off. We don't want to put any dimensions on that aren't necessary. We also don't want to show any dimensions in more than one view. Why do you think that? Why do you think it's important to only show a dimension one time on a drawing? Go ahead, Hans. In case you change a dimension, if it doesn't get changed in all the places, and probably it won't, then all of a sudden there's confusion. If somebody sees the dimension here, but then it was over here, was the right one, and whatever it might be. Yes, Hans. I'm not worried about the quiz right now. Please don't ask me about the quiz. Don't care. Don't care. You're not supposed to even do the quiz until after. I think there's a note on the top, isn't there? You're not supposed to do it until after we go through this. Okay. So please, I'm not worried about the quiz. All right. Additionally, anything that is a circular feature, a full circle, is going to have a diameter symbol in front of it. Okay. And it's going to be called out as a diameter. If we have an arc or a half, then it's going to be a radius. Okay. So, so make sure that you do that. And then also always default to symbols. Okay. This symbols, especially when we're working in a global environment, you know, through may mean something different in Germany than, you know, someplace else. So using the symbols is more universal. So try to default to that. And actually, Creo does a nice job of, you know, helping us do that. One last thing, you'll notice that there are center lines that are connecting, if you would, all of the features that are in line across. Okay. That means that they're all on the same value. Now, sometimes when they're closer together, if you try to get an extra little line in there, it might be a little much, but especially when you have patterns of things, make sure that they are connected by center lines so that you can see that they're all related by whatever dimension is being called out. Okay. So that's good practice as well. Okay. Any questions just kind of as we look at this, or any comments besides anything on the quiz? I'm not worried about the quiz right now. Okay. All right. So then let's turn the page. So let's kind of keep going here. All right. Oh, the next section here says fractional and decimal dimensions. Okay. So do not use fractions. You'll actually probably, none of you are old, but you'll date yourself, because fractions haven't been used for probably 20 years. All right. Everything is going to be in decimal. Everything is going to be decimal. And then it just depends. It just depends if you are in, if you're in, you know, 2 place, 3 place, 4 place, and such. The only place that you may see fractions crop up is when you might see a thread call out. Okay. Sometimes they show fractions then. Jacob, you want to put your hand up? I can see it.
Well, say that, like, or at least my job, we prefer fractions. We don't put them, but because we have to, like, get the parts and figure out where we gotta put stuff off of their drawing. It makes it worse.
Well,
we're using tape measures.
Okay. There might be some exceptions to that rule, but you can still, when you're calling out to, dimensions for decimal, for instance, there is 2 charts here, starting on page 201 and going over to 202. When you have a decimal, for instance, you do want to keep everything to nominal sizes or basic sizes. So if I'm going to be calling out an 1/8 inch diameter hole, yes, it's going to be an 1/8 of an inch, but I'm going to use the decimal equivalent of it. So when it's a 2 place decimal, it's 0.13. And if it's a 3 place decimal, it's 0.125. And if it's a 4 place decimal, then you add the 0. Okay, so then it is still a fractional dimension, but it's in decimal form. Okay, and that is the accepted way to put it on per the standard. Okay, so don't use any fractions. Again, like I said, you may see it crop up in a thread call out, but even then, instead of putting a quarter, it should be 0.25. Okay, so keep that in mind. And then basic sizes are important. Okay, now, and you'll see this on drawings or even models that we do. And I want you to think about this. So for instance, if you see a dimension like 0.13, okay, 0.13, don't draw it to 0.13, draw it to 0.125 because it's 1/8 of an inch. Okay, the same thing, for instance, with 7/32, 0.22 is 0.2188 or 0.21875. Actually, draw it to the actual basic size, and then your CAD system is going to do the rounding for you. Okay, so when you see those things that you're like, oh, 0.31, it's probably 5/16. And if you're on an English drawing, that's what you want to do. You want to put things to the basic sizes. So this is, I really like this chart a lot because it takes you all the way from, 1/64 and 1/64 increments. And if we go to the next page, it takes you all the way to 1 inch and what the accepted values would be. Okay, and what the accepted values would be. So use that as a reference at times. And the expectation is when you get out in industry that when you're working in the English system, you are rounding things to the basic sizes, because that's what tools are going to be made to, and that's what materials are going to be made to, and things like that. Okay, you don't want to willy-nilly make it to some obscure decimal, because people are going to be like, what is that supposed to be? Okay, they're always going to try to like bring it to one of these fractions. Okay, because that's how we work. Okay, in the metric system, you would go then to the nearest millimeter or the nearest 5th millimeter or something like that. Okay. All right, dimensions. All right, for angles. You guys see anything on this side that is a very big problem on this one? Anybody see what's the big problem on this drawing, on this view? Go ahead, Josh.
The angle is like,
yes, the angle is in the part. Never, ever, ever do we dimension on a part. I don't care. All day long, somebody might, oh, it's much more clear, I can see it. No. That is like absolute will not do. There is no reason to do that at all. You've got to create then an extra view or a section view or something. Okay, cannot dimension on the part. Cannot dimension on the part. Okay. The angle in this form, what we would do, we have a couple options. We could pull it off and we could put it here. All right. Or we could also probably go off the part in that direction and pull it off as well. Okay. When we have dimensions on views, each one of these dimensions has a tolerance. If it is not specifically right there, where does it default to? This would be on a title block on a drawing border. So if I'm looking at 2.69 and there's no tolerance immediately in back of it, where do I look for its tolerance? Because it has one. Nope. It would be in the title block. The title block always has an actual default title or default tolerances for 2, 3, 4 place decimals, whatever the company has. Is everybody familiar with that? Go like this. If you had me for tech drafting, it is, right? But I don't know if you had somebody else, but you should have had that. Yeah. I know there's not a title block on this particular one, but every drawing has a title block, and you will default to the title block for the standard tolerances. Now, if the title block has 2 place decimals and 3 place decimals, the only dimensions that can default there are 2 place and 3 place. If you put a 4 place decimal place on there or a 1 place decimal, guess what? What's your tolerance? Somebody's going to come and see, what's your tolerance? What do you need? Because the title block doesn't have those. So whatever decimals you leave without tolerances, there better be a reference in the title block that's going to let you know what that tolerance is, because every dimension has a tolerance. Okay. The other thing that every dimension has is 2 arrowheads, always 2 arrowheads. Sometimes And I don't think we see it here, but, where was that? Let me go back over here. We look at these dimensions. Oh, here it is. Yeah. That's where it was. Here, here, and here. These are 3 dimensions. How many arrowheads do you see? You don't see 6. That's a problem. All right. I'll call you on that every time. All right. You need to shift one up or down. Okay. Every dimension needs 2 opposing arrowheads. Every dimension. All right. So sometimes people try to sneak these in, but don't. And you might think, oh, it's saving room and it looks fine. Nope. 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 Yes. What? The radius? No, because it's a radial dimension. So neither do diameters, right? Yeah. Locational size, that type of thing. Yes, you're right. Okay. Arcs. When we're dimensioning arcs that are not full circles, we put an R in front of them. Okay. We put an R in front of them. In Creo, you have to choose one or the other. So make sure if it is an arc, make sure it has a radius call out. Okay. That it doesn't have the diameter. Okay. And then also if you have multiples of something, it's the number and then the X and then a space and then the dimension. Okay. All right. When you have hatching, this is best. This is the only way. Why isn't this one okay? This is not okay. They have okay. The dimension is on the part. We absolutely do not do that. Okay. No clicking, please. And then you'll notice here, they're also on the part. Okay. Even though the hatching's over the top of it. So these 2 are unacceptable. This one is the only way. All right, the next one's down here on the bottom of page 205. You'll notice that this is I don't even like the way that they say it's preferred. This is the way to dimension. Okay, this is an acceptable to the standard way to dimension because all of our dimensions are off of the part. And we can clearly see where the boundaries are that of each one of the features and the part makes. When you have something like this, you have to look at these 2. And when you compare them side by side, this is not clear. This is not clear. You've got a lot of business going on. You're on the part and it just clutters things up. Now you've got a clear view of what the final part is supposed to be. They have to come off of the part. Okay. Right. Up on the top here. Oh, this is kind of referencing Creo. We're not going to worry about that. Dimensioning prisms. No, sorry. Okay. I'm not sure why anybody is clicking right now. There isn't any Creo work that we need to worry about. All right. As we look here on the left-hand side, this is correct placement, okay, of the dimensions. Now, it's not saying it's the only place that it can be, but you'll notice some things. Number 1, the dimensions are pulled off the part. They are not uptight close to the edges of the part. You need about a 1/2 inch from one edge to where the first dimension starts closest to the part. Okay, so make sure that you're trying to maintain that. You'll also notice here that we have a diameter symbol or a diameter going all the way through. Whether those arrows are in the inside or on the outside, that's okay. It doesn't really matter as long as there's room and it's clear what it's referencing. Notice here that the dimension to the center line is where we see the feature as an object line and where it's dimension. It's always good practice to where you put the size dimension for a feature like a hole, in that very same view, put the location. So you're not looking around in other views for where that location is. Think about if you were to make this, what would be the easiest way to find these things? Okay. Over on the right-hand side, couple things. They're dimensioning to a hidden feature. They're dimensioning to a center line that's to a hidden feature. Not acceptable. When you see the cutout here, you might be like, well, that's the width of the cutout. Isn't it easier to see a cutout up here? So we always want to dimension where we see the feature more clearly in its like true view. So yeah, that's in projection, but it definitely makes it more clear if we have it there. The same thing for the thickness of the foot or the depth of the foot. All right. The depth of the foot is to the hidden line over here. Not good. Creo will do this stuff all day long. You cannot leave those there. It's still your responsibility to clean these up and put them where they're supposed to go. So bad business. Okay. Good business. What's the problem here? And online, you guys can chat too. I'm kind of watching the chat here, so feel free to chime in. What's wrong with figure 7.12, the dimensioning of solid cylinders? Go ahead, Josh.
You're showing a dimension for a diameter on the side view instead of looking at
Actually, when we have cylinders that are solid, okay, and they're, if you would, they're kind of like the ODs, this is okay to do them like this, but placement is not good here because it's on the part. You would need to pull these off, okay? You would need to pull these off. Additionally, these are all in a row here. Do you see how they're kind of hard to distinguish, like which one is which? You would want to, even if you pull them off, you want to stagger those up and down so that they're, you know, you can kind of see where the dimensions are. Okay. So actually a solid cylinder, dimensioning the length and the diameter in the same view is acceptable. Okay. Even though this isn't a circular view, but because it's a solid cylinder, it's okay to do that. And then, but placement here would just be staggering them, you know, to the sides and then up and down. So let me see here. I'm on page 210. You know, the other point to make too, for instance, when we have views, so let's say we would have 3 views, you know, 3 standard views. You always want to, that's probably your first consideration, but if you only need 2 views, don't do the third one. Okay. You don't need to clutter up the drawing with the third one. And also make sure that if you find yourself not putting dimensions on a view because you don't need to, then it probably is your clue that you don't need it. So for instance, over here, they only have 1 dimension on here. You definitely need at least 2. So I am not saying get rid of this, but I would probably put my 3-inch dimension over here or put it on this one, just so that you're using that view a little bit more. But other than that, I think this is pretty well done. Notice they've got gaps on everything. You're going to be looking for that. Notice that they've got the staggering. There's no crossing of extension lines and dimension lines. So dimension lines are anything that has an arrowhead on it. Okay. You don't want anything crossing over it. All right. There are at times when you may not be able to get away from it, but that is the exception. Okay. You have to do everything you possibly can to not cross dimension lines. So these are extension lines. Okay. Dimension lines are the ones with the arrowheads. So this one looks pretty good. Oh, here. So on page 209, this is where they're showing us how to properly dimension like vertical or horizontal cylindrical features. So yes, you can put the diameter in the rectangular view because it's actually a little bit easier, especially when you have a number of different diameters that might be going that are stepping down. So that outside diameter and then the overall length in the same view. Okay, and then horizontally, it would look like this. Okay. I'm going to kind of keep going here. I'm not going to hit each and every one of these. Couple things about slots, for instance, or elongated holes or dimensioned rounds, you know, that are on the ends here. So you'll notice that they've got a radius of 1 here, and that is going to then set the width or the height of this part. And then they added a reference dimension. How do I know this is a reference dimension right here? How do I know that 2-inch dimension is reference? Go ahead.
Right.
Yes, remember the standard way, the kind of the shortcut way of showing a reference dimension is parentheses. That's actually your first preferred way to put them on. If you put a reference dimension on in Creo, I think it automatically puts the parentheses around it if I recall. But that's going to be the way. You can see REF in back of dimensions, but again, it's the old way of doing it. So the current standard is parentheses. Notice that they're calling out the center lines for where those radiuses are going to be, but you could also do it like we see down here where you go on the outsides, but then you wouldn't do the center lines, okay? Because then your radius is coming from here, half of what that height is, and then the reference dimension is going to be on that radius, okay? So now, if you start going off on your own, I don't mind if it doesn't look exactly like mine, but then what I'm going to be asking you for is, oh, where did you see an example of that in the standard? And if you can't find a place, and that's what you want to do, because even when you go forward and you don't have my guides to go off of, you're going to want to know the standard well enough. You're going to want to know the ways to do it well enough in order to kind of make your own decisions. But also, if you're not sure, find it, look it up, okay? That's what these references are for. Couple ways to call out chamfers, okay? Calling out chamfers. Chamfers are going to be those angles that we put on things so that we can either have a lead in or we're going to be breaking, you know, some sharp corners. And to call them out, you'll notice that you can point to it and then just have, for instance, if it's a 45-degree angle, that means that it's going to be 0.1 in one direction, 0.1 in the other by 45 degrees, and you're done. You don't have to put anything else. You could also call it out where you give it the height and an angle as well. All right, that's fine. You'll also see sometimes general notes for chamfers. So then you don't have to even put it on the actual drawing. It might say all chamfers are, you know, 0.1 by 45 degrees, okay? And anything that's undimensioned would default to that. Okay. The next one here is going to be calling out holes that are on a bolt circle, okay? We're going to have that on one of the parts that we're looking at this evening, and that's going to be on the pulley, where we've got a number of parts and they're on this bolt circle, okay? So the way, first of all, that we're going to be showing the center lines is not going to be separate center lines on each one. Okay, that's what you're going to have the option to do. But instead, what we're going to do is we're going to put a circle and change the line type to center line. And that's going to represent the bolt circle. Okay, and then the bolt circle would be dimensioned, or you can add it as part of the note here. And that's what I actually have on the bolt circle note that we have on our pulley guide. So in this case, we're going to have 6 at a diameter of 20, and they're going to be equally spaced. That's what ES, that's an abbreviation for that, on a diameter of 57 bolt circle. Okay, and then the bolt circle is going through there. Notice we don't have the individual horizontal lines on here. That would get too cluttered. And really what we're emphasizing is they're all on the same bolt circle. Okay, so so you can also do it as a complete note. All right, either way. And trying to think if there's anything else. I'm just kind of trying to see what we have here, if there's anything else that jumps out at me. So I don't think so. I don't think so. Now at the very end here, starting on page 219, okay, you're going to notice that they give us a nice checklist for dimensioning. Take time to read through that. Okay, a number of the things that we talked about, you know, are on this list for good reasons. Okay, and this is 47 things to keep in mind. So there's a lot to remember. Now, before we leave this subject, what I do want to do is I'm going to go over to our module 4. And I'm going to look at that assignment number 7. Okay, assignment number 7. And I want to look at some of our guides. Okay, so I'm going to click on the guide here. And I want to talk about, I want to find out, what do you guys notice about these drawings? Okay, is there anything on here that you're like, oh yeah, we talked about doing this? Josh, go ahead.
All your dimensions have like a space in between.
Yes. All of them have the gap, right? All of them have the gap. I was gonna hear somebody else. Is somebody else gonna say something? No? What were you gonna say? All right, nothing. Smaller dimensions are underneath the longer, larger ones. Absolutely. Notice here, we've got two that are in line with one another, but they each have two arrowheads. Okay, two arrowheads. Now, this little curly thing, I don't know, remember I told you, these were the AutoCAD drawings. On Creo, you can get that right to the radius. So it should not be an issue. Just toggle it. Remember how we showed that? You have to toggle it. Yeah. Notice we have a diameter when it's a full circle, and it's a radius, and R in front of the dimension when it's just a radius. Okay. Notice that I have dimensions on all three views. Notice that I'm not dimensioning to any hidden features or center lines of hidden features. Okay. So dimensioning to this center line right here, no, not acceptable, because it's the center line of the sides of the hole that are hidden in that view. Okay. Any questions at all as you look at this, like, wait a second. Okay. Also notice that we have center lines, all right, on all the circular features as well. All right. Oops, I see something in the chat. The arcs are in radiuses. Yep. Thank you. Yes. All right. Let's look at another one. Let's look at another one. Wish I could just go back. Let's look at the anchor base. Okay. Let's kind of look here. We'll look at, I'm going to zoom out just a little bit. Now, a couple things about how the views look. All right. Now, these are on B size drawings. I realize that, but you're going to be filling up, your A size, just plain border for right now. Notice that they're taking up a considerable amount of the space. They are the stars of the show. Okay. When I'm making a drawing of a part, that should be kind of spaced out and as big as possible so that I can then add my dimensions and I can see everything. I don't want things to be small and crowded. So you wouldn't want three views right here in the center or down in the corner. Use the space. Okay. Use the space. Make them large enough. All right. The scales that are here are not going to be the scales that you'll use on the, the sheets of paper that you're going to be using. So just fill it up, make it look good. All right. All right. What else do we see here? What else do we see? Zoom in a little bit. You don't have like multiple callouts for the holes. You put like a 2 times in front of just one of the hole. Exactly. Creo, when you pull this in, if you make these as two separate holes, there's going to be a dimension on one and a dimension on the other. Don't put them on both. Okay. Just pick one that you're going to go with, and then you have to change it so that you have a 2 by, right? And the diameter. I have it. How do you connect center lines? Oh, I'm going to show you guys that. You have to actually do it in the sketch. You have to do it in the sketch view. And then you have to change the line type. So I'll show you how to do that. Not in the 3D model. Nope. It's going to be in the drawing itself. Yes. So this would be created in the drawing itself. Yeah. Notice radius is called out for not full circles. Diameters are going to be on the full circles. We've got our gaps again. Okay. So, so there's no dimensions on the part, as we can see here. All right. Let's look at one more before we kind of move on here. I'm going to look at the index feed. Okay. So notice here, we've got some angular dimensions. Notice that they're off the part. Okay. They're not on the part. They're pulled away. Now, this you won't be able to do in Creo. So depending on where you want to put this, but you see how in AutoCAD we could create that gap. All right. You won't be able to do that in Creo, unfortunately. This dimension line is going to, I'm sorry, the extension line is going to have to cover or go over to the top of a dimension line. So only in extreme cases, you know, do you allow that to happen, but you should be able to avoid it in other places. But yeah, this one is a problem. Now this one is okay. Why is this okay? The arrowheads, the dimension lines aren't being covered up. This is extension lines can cover or can cross each other. These are extension lines, not the dimension lines. So extension lines can cross, dimension lines cannot. Dimension lines cannot. Oh yeah, the tolerance here. Yep, I can show you that as well, where how you find that. So the tolerance here of 0.750 to 0.745, it is in the annotate tab when you select the dimension. So so I'll show you guys where that is. Absolutely, when we get over there. Yeah. Notice that we try to put as many dimensions in the middle as possible, but it wouldn't make sense to put these dimensions that are on the top of the part in the middle of the views, right? So you also want to be as close to the features as possible and try to minimize the length that you're, you know, pulling your dimensions over. Okay. So right now, I know nobody's going to ask any question. Are there any questions at the moment about dimensioning? All right. Now, for those who have snuck a peek at the quiz, do you still have a question, Hans? Oh. Oh, okay. I did answer it. Okay. All right. Awesome. Awesome. So what you should be ready to do. Now, I'm not saying like, go ahead and take that assignment number 8 quiz at this point. I encourage you to go through and read. All right. And read. If you're having problems sleeping at night, take this to bed. Try to read this for a little while. You'll get through a part of it, but all of a sudden you're like, oh, okay, I'm going to go to sleep now. All right. So it can cure insomnia, if anything else. Then it might take a couple nights to get through it, but that's okay. I encourage you to read it because honestly, that's how you're going to get to know the standard. And I can't emphasize enough how important it is that you know and understand the standard so that you can dimension. You will be golden at any company that you work at. They will absolutely adore you if you can dimension. I know it sounds silly and it doesn't seem like the most glamorous part of what you're doing here, but it is the most important part. It really is. So, so yeah, so you get to dimension, you get to really think about it. There's a lot to it. There's a lot of rules and there's a lot of things to think about. So, I want to encourage you then to look at assignment number 8 now that you're probably ready-ish. Okay. Remember 3 attempts on this one max. So you get the highest score out of the 3. And I think it's 40 points or 39 or 40 points or something like that questions. So true, false, multiple choice, a couple in there. So make sure that you, you know, take your time and really think about each one of those. And then as you're doing your drawings, review and make sure that they are abiding by the rules that we talked about tonight. All right. So I'm going to stop recording